I'm going to go through this question in three different ways. As I go through them, the different methods, the algebra is going to get easier in each method, but conceptually they're going to be more difficult. So you can kind of pick and choose which one ultimately you prefer. Would strongly advise you look at all three methods. I think I've learned a little bit from doing this question. I went with what is conceptually the easiest to understand method, however, the hardest algebraically. So I'm going to start with that one. All right, so I'm going to imagine that Granny, she's got her entire collection of antique spoons, and let's say that she's got X spoons. So she's going to give her daughter 8 more than a third of the total. So a third of the total is going to be a third X, and then we're just going to have to add 8 to that. So not too bad. And then we need to work out how many are left. So in this case, it's not going to be too bad. I can just sort of, I know I need to find something that I add to X. It's going to be 2/3 X minus 8. So let me just keep a little record of this down here. Okay, so that's how many are left. And then her son receives 8 more than a third of what was left. So that is going to be a third of this 2/3 X minus 8. And then 8 more, so plus 8. If I multiply this out, you can do it without multiplying it out, but I just felt like it was a little bit easier to, to not have lots of brackets. And I don't know, just when I did it, it just made sense to do that. We're going to get 2 over 9 minus 8 over 3 plus 8, which is actually 24 over 3 if I write it as a fraction. So it's, sorry, 2 over 9x. So 2 over 9x and then plus 16 over 3. There we go. Right. Now that is how many the son has. So I now need to add up how many the daughter and son have at this point. So it's going to be 3 over 9x, that's 1/3 x, plus 8 plus 2 over 9x plus 16 over 3. Okay, let me again write this as 24 over 3. So it's going to be 5 over 9x plus 40 over 3. Now that's how much is actually been taken up. So to work out how much is left over, it's clearly going to be 4/9 x minus 40 over 3. Because when I add these two together, I will get back to x, which is the full amount. So we've, like I said, this has been taken so far, and this we're left with. Okay, and then we're finally onto the neighbor, where we are told that the neighbor takes 8 more than a third of what was left. Well, first of all, the neighbor's actually going to take what is left. So they're going to take 4/9 x minus 40 over 3. But if we also incorporate this fact, then they are going to get 1/3 of 4/9 x minus 40 over 3 plus 8. So I've got an equation now, and I can solve that for x, and that will actually give me the total number. Okay, let me just bring it here. Okay, and this is what I mean by, actually, I think it's okay. Hopefully, you've followed what I've said there. Just taking it bit by bit. Um, done what it said. Have to work out what's left over. That's maybe the trickiest bit. Then applied it again and applied it again, and we're left with this equation. So hopefully you can follow that, but you can see it's quite a complicated equation. I'm going to talk about a possible method of solving it. So the way I would solve this equation is you could expand the bracket here, but I don't know. I just feel like it's best to deal with some of the fractions first before we do that. So I'm actually going to times both sides by 9. The reason being is that then I get rid of that 9 there. This is equivalent actually to putting a 9 here and expanding, putting a bracket around it and here. Okay, and then what you do is you basically times that by 9, times that by 9, and similar over here. Now, I'm actually going to get rid of that because I kind of think it makes it a bit more confusing. Instead, you can just think about times in each term by 9, but that is why. That's what we're actually doing. So I'm going to get 4x minus, when I times this by 9, the 9 is going to, and 3 are going to partially cancel. I'm going to be left with 40 times 3. I'm going to get 120. If you prefer, you can do 40 over 3 times 9 over 1, which will give 360 over 3. It'll give that minus 120. Similar over here, I can actually, if I times a third by 9, I'm just going to get 3. So I haven't expanded the bracket yet. And don't forget to also multiply that 8 by 9, so plus 72. Okay, next I will expand this bracket, so it's going to be 4 over 3x, because you can get 12 over 9, which cancels down to 4 over 3. Remember, this is 3 over 1. And then 3 times minus 40 over 3 will give minus 40. Okay, and I can combine this. So let me just write this out again. 4x minus 120. Combine that to give me plus 32 over here. All right, before I collect any more terms, I'm going to just times through by 3. Get rid of that other fraction. It's just always easiest to get rid of the fraction. So 12x minus 360 is equal to 4x plus 96. Okay, this is actually a lot nicer. So I'm going to minus 4x from both sides, 8x, and add 360 to both sides. That'll be 400 and 56. Now, actually, I remember when I did this question, before I even did this, I spotted that there was a factor of 4 in there, and I divided by 4. So you can go with what I've done here and do a little short division, but you know what? I'm going to return to how I actually did it. So if I divide through by 4, I'm going to get 3x minus 90 is equal to x plus 24. Okay, so this is much easier to deal with. So now I'm just going to get 2x is equal to 114. And therefore x is equal to 57. That is the number of antique spoons that Granny had in her entire collection. Okay, that's what I defined right at the start, created an equation and solved it. So we're asked for the sum of the digits of the number of spoons. It's just going to be 5 plus 7. Therefore, the answer is 12. Nice. Now, stick around. I'm going to show you a second method for doing this question. Not anywhere near as much calculations as here and dealing with algebra, but potentially a little bit harder to understand, but worth understanding, I'd say. Right, second method. This is actually courtesies of the official solutions. I think it's the solutions rather than the extended solutions. So we've got the daughter, son, and neighbor. And actually in this method, we work backwards. I'm going to say that the number of spoons that the neighbor was given is Z. So this was after, it was also the number left over after the son's share was removed. Just be aware of that. It's really important. So we can write down that because this is how many are left after the son's share removed, then it's also the bit that was what was left here. And we can write down as the first equation that the number this neighbor received was 1/3 of the number left over plus 8. And I could times through by 3. 3z is equal to z plus 24. 2z is 24. Z is equal to 12. So in a different way, I've managed to work out, oh, did I ever work out that this was 12? This would have been 12 here if you substitute x back in. But we've actually worked out how many the neighbors has received. So now I'm going to say that y is going to be the number left over after the daughter's share has been removed. I'm just going to write that down actually, because this is where it starts getting a little bit more confusing. So we've worked out how many the neighbor received and how many were left over after the son's share was taken. So let y be the number left after the daughter's share was taken. Because that is how much is left over, and therefore we can do y over 3 plus 8. That's how many the son is going to get. but that is also going to be the amount left over minus the number that the neighbor got. Okay, and this is where I think it's a bit like, whoa, what did you just do? So y was the number left over from the daughter, but we know that then the son is going to get some, but then the neighbor is going to get some, and the neighbor gets 12. So the son is going to get this amount, which is equal to this amount, y, but that's not, sorry, not y actually, y minus 12, because they don't get all of them. They don't get all of the ones that the daughter left because the neighbor gets 12. Okay, I've tried to explain it a second time. Hopefully you're happy with that. And from that, we can then work out y. So it's going to, if I can times through by 3 again, y plus 24 is equal to 3y minus 36. Therefore, 2y is equal to 60, and y is equal to 30. Nice. So actually figured out the neighbor's share, 12, figured out the son's share, 30. Okay, finally, we're going to do something very similar. And look how much easier the algebra has been. That's a nice thing about this method. So I'm going to let, just like before, let x be the the, the starting number of spoons, or the number of spoons in Granny's collection, I should say. Then that will allow us to work out, so I'll put x here, that will allow us to work out the daughter's share. And the daughter's share is going to be a third of the starting number plus 8. But it's also going to be this starting number minus what um, the other two received. And actually, I've just realized a little mistake because Sun didn't receive 30. The Sun would have received 30 minus 12, so 18 spoons. Well, that's actually not going to be that important, but y equals 30 was the number left over after the daughter's share was taken. So sorry about that. This is why it's easy to get mixed up in this question, I think. So, so this is quite important because x is the starting number of spoons. The daughter received a third of that plus 8, but would also receive the full starting number minus however many were left over for the son and the neighbor. And we see that that's actually equal to 30. So this is our final equation that we need to solve, working backwards, as we said before. So x plus 24 is equal to 3x minus 90. 2x is equal to 114. We're back to here, and x is equal to 57. So that's the starting number. We could even figure out how many the daughter must have received if we wanted to. So that is 30. So it must be that the daughter received 27. But it doesn't actually matter. It's nice to know. But from this 57, we could then again get the sum of the digits as 12. So that was method 2. It's nice. I think it's a bit tougher to get your head around, especially like this here. Once we're on a roll, it's okay, but it's very easy to, I think, especially this bit here, realizing that, yeah, we're using a number that's left over. The son didn't actually get 30. That was the number that was left over after the daughter had taken her share. Okay, anyway, that is the end of method 2. All right, one more method. This is actually, we're not going forwards, we're not going backwards as such. This method is more of a recursive method. You'll see what I mean in a minute. So let x be the number of spoons available before I should say some are taken by the next person. Okay, then 1/3 x plus 8 is taken. by the next person. And 2/3 x minus 8 is left. So what we're going to do is we're going to set this equal to y. By the way, this is the hardest one, I think, to get your head around, but it is the nicest algebraically. Let this equal y. So we've got y is equal to 2/3 x minus 8. Let's just remind ourselves, x is the number of spoons available before some of them are taken. Okay, so we're going to have the starting number at one point, and then y is what is left over after. So I'm now going to make x the subject. So I can add 8 and then times by 3/2. Do you know what? I think I need a little bit more working to convince you of that. So 2/3 x is going to equal y plus 8. And I can times by 3 and divide by 2. That's what I was trying to do really quickly before. Okay, bit more justification for it. So this is actually really useful now. We've got a relationship between x, which is the number before we give them to the next person, and y, which is the number left. So let's consider the neighbor. And what we're going to do, we know that there are none left over after the neighbor's taken them. So we're going to put y equals 0 in this instance. After given to neighbor. And that means x is going to be 3/2 times 8. And that is 3 times 4, or 12. And so, again, we've worked out that the neighbor actually gets 12 spoons. And we can, what I mean now by recursively is we can now put, because that was the number left over after the son had taken their share. So now we can basically set y equal to that to work out how many were there before the son got their share. So put y equal 12 for after given to son. Then it's going to be 12 plus 8, 20, divided by 2, 10, x is equal to 30. Nice, that's what we got before in method 2, so I think it helps to have gone through the first two methods, to be fair, to get a head around this. Okay, so that is a number that were available before the son took their share. They didn't actually take 30 themselves. And then finally, that is the number left over after the daughter has taken their share, so it's going to become y. So put y now equal to 30. After given to daughter. So I'm being a bit slack here after the, certain number of spoons were given to the daughter. Then remember we've got this formula, so it's going to be x is equal to 3/2 times 38, which is 3 times 19, which is 57. So that is the number at the very start from which we get the digit sum, again being 12. Okay, I think this one is this one is like messes with your head a little bit more. It's lovely though. It's like absolutely amazing if you were to think about, imagine if there were like 5 people, 10 people. Imagine the equation you would have got from method 1. Okay, whereas you basically have created a recursive formula, like an iterative formula, which is a topic that you might not have seen before. Fair enough. Okay, so you might not know what I mean by recursive, but we're just putting a number in, getting one out, putting that one in as a new value, getting a new value out, and you could like repeat it. So this is why this method is so good. They've all got their merits. Like I said, method 1 intuitively the easiest, I believe, but the hardest algebraically. Method 2 works backwards using the same idea as method 1. Harder to get your head around, but easier algebraically. And then method 3, just throwing the rulebook away really, and just, it's lovely, just considering how these two things, x and y, relate to one another, and they relate strongly to one another. So as we go along, we can just put a number in, get a number out, put that number in, get a number out, and it all works out really well from here. Okay, so just want to say thanks for watching this whole video. You're amazing. And I hope you enjoyed this problem. I think, when I did it, I was like, yeah, it's all right. I think actually going through it and seeing the different methods was the best bit about it. So yeah, well done.